Hello again and welcome back to the wife's sewing room. Today a very special treat indeed, a Commodore 2031 floppy disk drive. This floppy drive is for the Commodore PET. I have a Commodore PET 4032, but until now I've never had a floppy drive for it. I've just been using a tape drive. I picked this up on eBay just recently. It has a few flaws. There's some corrosion on the top here, and honestly I'd be surprised if it works, but first things first, open it up, do a visual inspection, clean it up, see if it works. It doesn't look too bad on the inside. It's a little dusty. We'll do a quick visual inspection, and then first things first, we'll check the voltages. Taking a look at the insides, I noticed a few things. Someone had previously done some repairs to this section here. These chips are all socketed, and there's a jumper wire right there, probably a damaged trace when someone removed the chips previously. And unfortunately, this IEEE connector right here looks like it was held in with rivets, and the plastic has split on both sides here where that rivet is. So someone has epoxied it back into place. And the nuts that you screw the connector onto are missing. This area right here looks like some work's been done to it, but this was done at the factory. I found this in the service manual. This is an upgrade note. It was a design error present in the original design. Right circuit was modified to correct the problem, so this was a factory done modification. I opened up the can on the clock circuit just to take a look. It looks fine. We have a couple of ROM chips. We have the 6502 and a pair of PIAs 6522s. One of those is for the IEEE interface and the other one's for the disk I/O. I'm going to start by checking the voltages. I have the transformer, the AC transformer output, disconnected from the main board. Voltmeters on volts AC. Turn it on. So we have 16.4 volts on the two outside pins, and there's 9.85 volts on the two inside pins. Next, I've reconnected the AC output to the board, and I have the meter connected up to the filter capacitor on the output of the rectifier, but before the regulator. I'll switch to volts DC, turn it on. We're getting 10.5 volts on one of the capacitors, and we're getting 19.1 volts on the other. Now I'll check the output of the regulators. So here we've got 11.89 volts, that's fine. And over here, 5.2 volts, that's fine. So does it work? Well, the answer is no. The drive light comes on, but it stays on. It should go out immediately, or it should flash error codes depending on the problem. According to the service manual's troubleshooting section, error LED stays on all the time. Check the 6502 microprocessor, check ROMs. Well, I have checked the 6502 and I have checked the ROMs. I swapped the 6502 with the one in the PET, and the chip that's in here now runs the PET just fine, so that's good. And for testing the ROMs, that's a little tougher. I took these out and I plugged them into an EEPROM programmer on my PC. And I can read the contents. These are returning data, they're not just completely dead. I can't be sure that the contents are correct, but they do appear to be working. So if the CPU and the ROMs are both okay, but the system is still not running the startup diagnostic routine, what could be the problem? The clock input is on pin 37, yes, and that actually looks fine. There's a power on reset signal that comes from a 555 timer and then goes to an inverter on UA3. Power on, it stays low for a few seconds and then goes high, so power on reset looks okay. Well, my theory now is that if the system is not starting up far enough to get diagnostics, then perhaps even if the ROMs are good, it can't read them, which would mean there's a problem with the address decoders for that. It's kind of hard to do without getting in the way of the camera. I'm going to try. I'll leave the camera on the scope anyway so you can see. What I figured out is, we look at the chip select on the ROMs, 24, 23, 22, 21, 20. The chip select line is not stuck high or low. It's active, it's doing something, it's live, so it's probably fine. The other ROM, 4, 3, 2, 1, pin 20. There's the chip select line on the second ROM. So I'm guessing the address decoders are okay. The system should issue a flash code at startup if there's a problem with zero page or with the ROMs or with RAM. It could be bad RAM, which seems pretty likely, but if it was, I would think that the system would be flashing the LED. I don't know why I didn't think to do this before, but I went ahead and swapped the 6522s one to the other, and it didn't seem to make any difference at all. The light still comes on, stays on, no sign of motor activity. I run into something a little confusing. The schematic shows U6J, a 74LS42. Well, there is no U6J. U6 up here, F, H, K, L, no J. What's more interesting is the parts list has no U6J either. U6H is the right part number, 74LS42, and it's the only one in the entire parts list. So this must be U6H and not U6J. These are the chip select lines for the two PIA chips. The chips are definitely being selected, so I think the address decoders there are okay. I've made a bit of progress. The motor spins now. All I did was manually turn the shaft a little bit. It might be some dirty brushes. One of the things that I've noticed in testing here is that the behavior is intermittent. Here I've got the probe on pin 23 of the 6502, which is one of the address lines. You can see it's toggling. The address line is changing. And look at the chip select line for one of these ROMs. That's 24, 23, 22, 21, pin 20. You can see that's toggling too, which means the address decoder is addressing this chip periodically. However, strangely, turn it off, turn it back on again, and the address line is no longer toggling. It's just a steady high. I think what this means is the CPU is locked up. CPU is not processing at this point. CPU is good. So what I think is going on is that we have a bad ROM. I think the ROM chip select line on that ROM is low now. I think the ROM is just spitting out random data and the CPU doesn't really know what to do, or it locks up. So even though the service manual says that there are LED flash codes that might indicate a problem with the ROM, you got to at least be able to run the diagnostics routine that flashes the LED, which I don't think we're able to do. This is the high memory ROM at U5F, and I'm pretty sure this is the startup code and this is the one that's dead. So trying to source a replacement ROM is not going to be easy. I've got some EEPROMs on order. I might go that route, or I might be able to find an actual correct ROM for this one. But that's going to take a little while. So in the meantime, I'm going to disassemble the whole unit and give it a thorough cleaning. The belt doesn't appear to be in bad shape. The speed adjustment wheel fell off of it. That cleaned up nicely with a little isopro and a stiff brush, so that must have just been glue residue. Now I've got the wheel, and I'm just going to use some double-sided tape to stick it back on there. I like to use double-sided tape for labels like this because it's flexible and it's removable. There we go. While I've got this drive mechanism removed, I wanted to go ahead and clean it out. I have blown out all the dust and wiped it down, brushed it out. But the guide rails here are a bit rough and a little bit sticky, so I'm going to go ahead and clean those. These shoe guard drives, the official service manual on them say specifically never apply any oil or lube. They don't say anything about cleaning, but I think it's a good idea to clean them sometimes just to get the stickiness off the rails so they move easier. Over the years, dust accumulates on them, or I don't know how they get sticky, but they do. I'm just using a cotton swab with some isopropyl alcohol. Kind of squeaky. Now, blowing it out with the air compressor revealed another problem. The compressed air got up underneath the paint, and apparently there's been a lot of rusting, a lot of corrosion up under the paint here. Air got up under the paint and just started flaking it off in large chunks. So all back here around the grill and up here on the inside in the corner, a little bit around the sides, and here there's definitely a lot of corrosion in there. I want to get a handle on this corrosion, so I'm going to completely disassemble it, take out the transformer and all the other parts so that I can completely submerge it and scrub it. I cleaned up the corrosion as best as I could. I lost some paint on the front here. A lot of it on the inside and a lot on the back around the grill. It's down to bare metal. The corrosion's scrubbed off, but especially on the bottom, you probably can't see it here, but there are lumps under the paint. The paint is lumpy here where there's definitely corrosion under the paint down here. Eventually it's gonna start corroding again. The only solution I can think of is to completely strip it and repaint it, but that's going to wait for another day. Now I'm going to try to put it all back together. I have that ROM chip adapter on order, so I can use an EEPROM. Should have that on Friday. Be able to hopefully get it working this weekend. Time to reassemble the power transformer, the switch. On here, and one on here. Also give these a little bit of strain relief. and we'll blow some hot air on. Now it's put all back together, and before we had taken it apart, we had the symptom of power switch. Drive light and motor stay on continuously. So I diagnosed that as a bad ROM. So what I've got today is an EEPROM to replace the bad ROM. I've already programmed this with the contents of this suspected bad ROM. The problem is this Commodore ROM is a 2364. It's an 8 kilobit ROM, and the replacement ROM is 28 pins instead of 24 pins. So an adapter socket is required. This adapter socket swaps around the necessary address pins to make this chip compatible with the one that's in there now. So, pull out the probably bad ROM chip. I put the EEPROM in the adapter socket and put the adapter socket on the board. Now there's only one thing left to do. Smoke test. Oh, that didn't help, did it? Looks like we have the same symptom. That light should come on for a second and then go off. I've messed with the socket adapter and double checked the ROM in the U5F position, the -05 ROM. And just on a whim, I thought, well, let's try replacing the other ROM while we're at it. So now we've got both ROMs replaced. Let's see what happens. The light and the motor went off. I think that's what's supposed to happen. That could be a good sign. Next step, I guess, would be to plug it into the PET and see if it works. Well, I've got my trusty PET 4032. Got everything plugged in. Let's turn the drive on. And let's turn the PET on. That's expected behavior. When the PET turns on, it should reset the drive. I have Commodore factory floppy drive here. This is the VIC-20 and C64 terminal software, but we should be able to get a directory off of it. Let's see what happens. Directory. Holy moly. Look at that. She's alive. Got a blank double density floppy here. I'll try initializing a new disk. Header. New disk. The format of the command. Drive letter. Comma D0, comma I, and a unique ID, AZ. Yep, let's do it. This 2031 uses DOS 2.6, so it should function exactly the same as a 1541 drive and should be read and write compatible with a 1541. New disk, 664 blocks free. Now it's working and all put back together. Got it sitting next to its cousin there, the 1541. There's still a lot of cosmetic issues, but I'll save those for another video. For now, I'm just happy that it's working. Thanks for watching.